Okay. So my mic is up. Okay, great. So hi there, good morning. My name is Molenkamp. I'm a principal cloud architect working for InfoSport, which is an IT consultancy company in the Netherlands. Really glad to be here. This is actually my first time here at NDC London. So yeah, really excited. So the topic of today is actually going to be two topics. We're going to talk about Dapr, we're going to talk about Azure Container Apps, and especially how we can combine these two technologies into this really powerful, flexible serverless platform for running your containerized applications. Now, I've been working with a customer in the Netherlands for quite some time now. They're a company in the energy utility sector, and they have a growing number of .NET microservices, which they run, most of them anyway, in Azure App Services. And generally speaking, they are actually quite happy with that. App Services really easy to get to learn. It's easy to deploy your .NET applications to, right? Now, over the last couple of years, they've been starting using containers more and more. They really like the portability and the isolation it gives them. But it still deploy those containers to Azure App Services. And you can do that with its web app for containers feature. So even though they are quite happy with this, there are some downsides because Azure App Services, it's really optimized for running web applications, right? So it's optimized for running one or maybe a couple of containers really well. And they're not just building web applications, they are building these large microservice solutions consisting of many moving parts. And so ideally, they'd like to have access to some more advanced features, more geared towards microservices. Things like traffic routing and service discovery. Things you really want when you need, where you get a lot of more different microservices. They also like to have some better scale-out capabilities. You can scale out, of course, with Azure App Servers, but if you do, you scale out the entire app service plan, and they'd like to have some more fine, more granular control over that. So if they are building microservices, and if they want all of these nice features, then why not just go to Kubernetes, right? Because it will do all of that for you. Well, they are very hesitant to go to Kubernetes because frankly, they don't need all the flexibility that Kubernetes will offer them, and they basically don't want any of the complexity that Kubernetes will give them. Because, let's face it, Kubernetes, even on a service like Azure Kubernetes servers, where a lot of it is managed for you, is still a way more complex service to use than Azure App Servers, and that's simply because it does a lot more. So you get this higher complexity. So they are a bit stuck in the middle here. App Services doesn't offer them enough. Kubernetes gives them basically too much. And as you might have guessed, this is where Azure Container Apps comes into the picture. So with Container Apps, we get basically this serverless platform that we can use to run our containerized workloads. It still uses Kubernetes under the hood, but you don't have to deal with all of the lower level implementation details. So you don't have to deal with that Kubernetes API directly. Instead, you work with this opinionated, high level of abstraction that still gives you advanced features like traffic routing and HTTP ingress and service discovery without having you go to that Kubernetes layer directly. So basically, you are trading some of the flexibility that you get with Kubernetes for a lot more simplicity and ease of use. So this is basically a perfect fit for them because now they can simply focus on building those microservice applications. They still get some of those advanced features they want without having to worry about many of those implementation details. So they are currently evaluating whether or not this is really a good fit for them. It's still fairly new, Azure Container Apps. And they're doing some proof of concepts. Now, unfortunately, I cannot show those to you today. But I do have this other sample which we can use to further explore Azure Container Apps and also look into Dapr. This is my traffic control sample, so you've probably got this also here in the UK. In the Netherlands, we have a lot of these speed control trajectories where they use cameras above the roads to snap pictures of your car, at least of your license plate. And then at the start of the trajectory, they take a picture, and then at the end, they take a picture. They can calculate your average speed. And then, of course, if you've driven too fast, you get a fine, a hefty fine, I should say. So if we want to automate this, I have this solution which consists of 3 main services. So first of all, we have the traffic control service. This is the service that will receive the events from the camera. And it is responsible for calculating that average speed and then determining whether or not there was a speeding violation. So if it detects a speeding violation, it will rat you out and it will tell it to the fine collection service. The fine collection service then responsible for calculating the exact fine amount and sending you an email with the speeding ticket. Now, in order to be able to do that, it needs some more information which it can get from the vehicle registration service. So these 3 services are the main services. There are a couple of more, but we'll get into that later. Now, if I want to deploy this solution to Azure Container Apps, the first thing that I have to do is create an Azure Container Apps environment. And then inside this environment, each microservice will run inside its own Azure Container App. So for those of you who know Kubernetes, Azure Container Apps is basically just a Kubernetes pod. Right? So it can run one or more containers, and it's the unit of scale. So each of these container apps you can scale and deploy individually. Now, if I want to do a demo for this, we obviously need some data, right? Because otherwise it would be a boring demo. I don't have any access to traffic cameras, at least not at the moment. So I've got the next best thing, which is this simulator. It will simulate some cars driving by on the road. It will generate those entry and exit events, and it will push them to the traffic control servers. And I will be using MQTT for that. That's a really lightweight messaging protocol, which is pretty often used in IoT scenarios. So where does Dapr fit into all of this? Because up till now, we've only talked about ACA. I'm going to call it ACA, by the way, because Azure Container Apps will get, it's a bit long-winded. So Dapr can make it a lot easier for us to implement this microservices solution. Dapr originated within Microsoft as an open source project. It's a couple of years old now. I think it's about 3 years old, something like that. It's also been adopted by the CNCF. And what it basically is, it's this set of building blocks that makes it easier for you to create microservice solutions or distributed systems. So there's a lot of different building blocks in here. And what's nice about these building blocks is that almost all of them are pluggable. So you can use different types of components with them. So as an example, let's take the state management building block. So state management allows you to create these stateful services by allowing you to store key value pairs in some underlying data store. And there are many different components that you can choose from. So I could choose a component that stores my data, let's say in Azure Table Storage. And then later, if I change my mind, maybe I want to switch to MongoDB, I can use a MongoDB component. And I don't need to change my code. It's only the component configuration that I need to change. So that means that Daprized applications are very reportable and very easy to move between different environments. What's also very interesting about Dapr is the way that you use these from your application. So Dapr is not a library or a framework that you have to link inside your application at compile time, stuff like that. Instead, you talk to it using the Dapr API, which has 2 flavors, HTTP and gRPC. And then your application runs in its own process. So if I'm running this on my local development machine, there's 2 processes running side by side, my application and the Dapr runtime, and they talk over this API. Now, if you are running this in production, the Dapr team actually recommends that you run it in Kubernetes. So that would mean that I have a container with my application code, and I have a container, the Dapr sidecar container running the Dapr runtime, and those would run together in a single pod. So this sidecar architecture is really interesting because this means that you basically can use any language, right? Because any language that can make an HTTP or a gRPC call can work with those Dapr building blocks. So that makes it really flexible, especially in larger microservice scenarios where you maybe have different teams working with different languages and technologies. All right, so normally, if I want to use Dapr, I would spin up my Kubernetes cluster for production and I need to deploy Dapr into it. But with Azure Container Apps, Dapr is basically built in out of the box. So the only thing we need to do is to specify on a container app that we want to use Dapr, enable it. And then Azure Container Apps will inject the Dapr sidecar for us. Now this is not a nothing or all thing. I've enabled it here for all 3 services because I want to use Dapr in all 3 of my services, but you can also enable it for a single service or 2 out of 3. All right, so let's switch gears for a moment and see what that actually looks like in the Azure portal. If it's still running, because great timing, but this morning there were some issues in Azure. I tried it all out. It still worked this morning, so I hope it's still working now. Yeah, so let's start in Visual Studio. So this VS Code with my solution, is it visible in the back? Is it okay? Yeah, awesome. So I deploy this solution to Azure using bicep. So here my deploy folder, let's see, where's my cursor? There's a lot of bicep modules. And if we dig here into some folders, then for example, here is the bicep module for the traffic control service, which that service that will receive the camera events. So this takes in some parameters. We have the location, so the region where we want to deploy this. We have the, this is deploying a single Azure Container App, right? So we need to know the ID of the environment where we want to deploy that app into. Then I also have this managed identity ID. So this is the name of a user-assigned managed identity that I created to let my app integrate with some other Azure resources. And then down here on line 9, we can see the actual resource definition of the container app. Now we need to give the name, we need to give it that location. I assign that managed identity. And then we get to the properties, where I'll set the environment ID. And then finally, here in the template section, we can specify which container we actually want to run inside this app, which is a container that I pull from my public Docker Hub repo thingy. Now notice this is an array. So within a container app, you can run multiple containers. And that's the scale unit, so they will scale together. But as far as scaling goes, I'm keeping it simple for now. So here I specify that I want to have basically exactly 1 replica. And we will not do any autoscaling yet, but we'll get to that. And then finally in configuration, I need to set the active revisions mode. So what's a revision? Well, a revision is basically immutable snapshot of a version of your application. So let's say that I've got this great new feature in my application, but I only want 20% of the requests coming in to use that new feature, just to try it out, like doing a little canary testing. Then I can set the active revisions mode to multiple, and then I can add traffic rules so that 20% of the traffic will go to the latest revision, and 80% of the traffic will go to the older revision. Now, in this case, I'm simply using a single revisions mode, which means that 100% of the incoming traffic will always go to the very latest version of my app that I've deployed. And then finally, on line 34, we get to the Dapper part. So here I enable Dapper to inject that sidecar. Each Dapper app also needs to have a unique ID. That's the Dapper application ID. So I set that to traffic control servers. And then this Dapper sidecar needs to know on which port my application is listening. Because most of the time I'm calling the Dapper sidecar, but sometimes the Dapper sidecar needs to call into my application, for example, to get some configuration or to trigger my application to start doing something. So my app is simply running on port 80. Now I've already deployed this, so we don't have to wait. So here I am in the Azure portal in the Traffic Control ACA resource group. So here you can see the container apps environment. You can see some container apps here, like the Define Collection Service, and you can actually see a lot of more stuff, which is all stuff I need and will get to. But let me first jump into this Traffic Control Service. And you can see that if I go to Dapr, you can see that it is enabled, and there's all those settings we just saw in the bicep module. And if I scroll down, you can even see all the Dapr components that are configured for this app. And what's really nice and useful for debugging and for these kinds of demos is that you can go to the log stream. It's always a weird alert because I didn't change anything. It still wants me to, I guess, discard nothing. So here you can see the direct output coming from the containers in your app. So as you'll see, the latest log line is from like 9 o'clock this morning. At 9 o'clock, this still worked, at least. So this shows all of the logging of all of the containers in your app, right? So this is my application container, but because there's also a sidecar container running there, I can also select that sidecar. And we will see the Dapr logs. So this is really useful to get a nice live view of what is happening inside your application. All of that logging is also dumped into a log analytics workspace. So if you want to do some longer term queries, stuff like that, you can use log analytics for that. All right, for now, let's go back to the slides. And let's dive a little deeper into our first service, the traffic control service. So this needs to get some data from the traffic simulator, right? And to keep the service itself nicely decoupled from the cameras and or my simulator, I'm going to use a MQTT message broker as a middleman here. So I'm going to use Mosquito, which is this very lightweight MQTT open source message broker. And what we'll do is the traffic simulator can push messages to Mosquito, and then other clients like the traffic control service can subscribe to process those messages, right? So it works just like any message broker. But of course, Mosquito is running inside of Azure, somewhere up there. And my traffic simulator is going to run on my local laptop. So we need to make sure those two can connect. And the way to do that is to set up Ingress on that container app. So with setting up Ingress, you're basically exposing a port to make it available to the clients. Now in this case, I'm talking MQTT. And MQTT is a TCP-based protocol, so I need to open up a TCP port. And usually with MQTT, that's 1883. That's usually the port that's used for that. So I can do that using this piece of bicep. Here you can see I've added an ingress part to my configuration section. Setting external to true means that I want that port to be available outside of my environment. If I leave it at false, only the other services within the same environment can access the port. So the target port is the port that I want to expose. On my Mosquito container, the exposed port is the port that the client is going to connect to. That is optional. By default, it's set to the target port, but you can do some port mapping there if you like. And then I need to specify the transport type. Now, originally, ACA only supported HTTP and HTTP2. And now TCP Ingress is in public preview, so I'm using that preview feature. There is one caveat though. You have to deploy your Azure container environment inside a custom VNet for this to work. So what I did for my bicep modules, I first created that custom VNet, and then I deployed that environment into that VNet, and now I can use TCP. So this works great. So now I have my events generated going up to Mosquito, and now the traffic control service needs to process those events, but how is it going to do that? So we're talking MQTT here, so I could go hunt for an MQTT NuGet library, inject that into my application, deal with it directly from my code, or I could simply not worry about MQTT at all and just let Dapr handle that. And we can do that by using a building block called Dapr bindings, or in this case, specifically Dapr input bindings. So with Dapr bindings, you can basically interface with external systems without having to worry about all of the lower nitty-gritty details. So what we can do is we can create a component configuration for a MQTT Dapr input binding. Then the sidecar will see that component. It will subscribe to Mosquito for us, and it will start to receive those messages. And then when a message comes in, it will trigger the application by calling an HTTP endpoint on the application. Now notice it's an HTTP, not an MQTT endpoint. And we can create very simply an HTTP endpoint because, well, basically we're doing that all of the time. So now my application doesn't need to deal, it doesn't even need to know that it's using MQTT under the hood. It only needs to expose that HTTP endpoint. And that's also really nice for testing, by the way. So let's see that in code. Let's first look at that component configuration file. So let me open up this again. Where did I put this? It's in my Dapr folder. So there are two input bindings here actually. So the entry cam is for the first set of cameras that your car will drive under. So what we see here on line 8 is the Dapr component for this. So each Dapr component needs to have a name. So I'm going to call this entry cam. And then you need to specify the component type. So this is a binding for MQTT, so bindings.mqtt. By the way, there are a lot of components. There are, I think they're up to like 124 components, something like that, over all of the building blocks. So, and you can contribute your own if you're missing something because it's all open source. And then in this metadata part here, you need to specify the metadata for the component. And the exact stuff that you need to specify here, of course, differs per component type. So in this case, for MQTT, we need to tell it where the MQTT host is by specifying this URL parameter. We need to tell it what topic we want to subscribe to. So for the entry cam, we want to listen to the entry cam messages. And then each client that connects to Mosquitto needs to have a unique ID. We don't know exactly how many clients there are going to be because if I scale out, I will get multiple clients, right? So instead of having a static value here, I just use this nice template syntax, which means, hey, Dapr, you figure it out. Just generate a unique ID for me every time you create an instance of this component. And then finally, we get to the scopes part. So by default, every Dapr component that I define is available to every Azure Container App running in that environment. You may not want that. You may want to scope it further to a single service or to a set of services, and you can do that using these scopes. So with this set up, Dapr will start listening to using this URL to this topic, and then it will alert my application whenever there's a message available. So if I look at the traffic control service, I have these nice minimal API endpoints. I really like minimal API for doing demos like this because everything is nice in a single file. So I've got two of them, entry cam and exit cam. And these are the endpoints that will get called whenever a message comes in. So how does Dapr know that I've named these endpoints entry cam and exit cam? Well, that's pretty simple. If we just go back to the bindings, it's the name of the binding. So if I change this name here, I also need to change the name of that endpoint. And I also have an exit cam binding, which is exactly the same. The only difference is it's called exit cam and it listens to a different topic. All right. Let's see what we'll do. Yeah, we'll go back to the slides for a bit. And talk about autoscaling just a bit, because now that we've decoupled stuff with that Mosquitto broker, it's very easy to scale out the traffic control servers to start processing more messages in parallel. And Azure Container Apps uses Kida for that. So Kida is a Kubernetes event-driven autoscaler. It's a different open source project which they've incorporated into Azure Container Apps. And we can use Kida to create rules like this one. So this is a really simple rule. It's based on CPU utilization. It just says a minimum replicas 1, maximum 3, and if you're really busy, go spin up another replica, right? So this is a pretty boring one, but Kida has a lot of different scalars that you can use. So for example, if I were pulling in messages from a service bus queue, then there's a service bus scalar for Kida that I could use, and then I can scale my app based on the number of messages in the queue. Now, unfortunately, there isn't a MQTT scalar yet for Kida. Otherwise, I would be able to use that, and we could scale based on the number of messages available in Mosquitto. So I'm just sticking with this CPU rule for now. So if the CPU load is high enough, eventually we will get to 3 replicas, right? Notice here that I still only have a single app, and within that app I have 3 replicas, all processing messages in parallel. Now, the very nice thing about ACA is that you can also scale down, all the way down to 0. And 0 is great because if there's no work to do, I don't want to pay for it, and I can just shut it all off. But While that's really nice, be really careful with this if you are using Dapr to trigger your application, as I'm doing here. Because if you're scaled down to 0, of course your application container is gone, but your sidecar container is also gone. And the sidecar container was the only component in my diagram that actually triggered my application to do some work. So with the sidecar container gone, nobody subscribed to that Mosquito topic anymore, and nothing will ever happen again. This will always stay at 0. Now, if we did have access to a KIDA scaler for MQTT, we could have used that. Then the scaler would detect, hey, there is some work to be done because I see a queue count higher than 1, and it would scale my application back up. So that would get us out of this problem. But because here Dapr is the only one triggering, and I don't have a scaler based on the infrastructure, I should definitely not scale down this solution to 0. Yeah, okay, so now we get in those camera events. So just to reiterate, we get an entry message that has a timestamp when the car reaches the first set of cameras. Then after a while, unless something horribly happens, the car will reach the exit, and we get a different timestamp. And then we can calculate the average speed, right? So the timestamp that we get at the point of entry, we need to at least keep somewhere safe until at least we get to the end of the trajectory. So this needs to be a stateful service. And to do that, I can use another Dapr building block called state management. So with state management, I can simply store key value pairs inside some data store to be determined, configured. Now this is really meant for like hot state or transactional state, small things like this. Don't replace your huge relational SQL database with states management. That's not what it's meant for. So I'm going to use this to store my state in Azure Customers DB. So to set it up, I create another component configuration file for that Customers DB, and then when I want to either save some state or get some state, I make a call to my Dapr sidecar, tell it what I want, then the Dapr sidecar will look at the configuration and it will talk to Azure Customers DB for me, right? Now, the nice thing about this being all pluggable and portable is that if I run this solution on my laptop, maybe I don't want to be tied to Azure. Maybe Azure is down, like this morning. And then maybe I want to use Redis for a state store because I can run Redis in a container on my laptop. In that case, I only need to change that component configuration file. Dapr will use Redis, and my application code can stay exactly the same. I don't need to change anything. So again, that's really flexible. I'm going to stick with Azure Customers DB for now while it's working. So after we've done that, we now have the speeding violation, and we need to tell the event collection service about it. And I'm going to do that asynchronously by publishing an event. And of course, there's another building block to help me with that called the publish and subscribe or pub sub building block. And that allows me to integrate with message brokers. So in this case, I'm going to use another component configuration to set up a connection to an Azure Service Bus. And then when I want to publish that event, I simply call into my Dapr sidecar. So let me show you what that all looks like in code. So let's go back to Visual Studio Code and basically continue where we left off. We were in the traffic control service with these two endpoints, right? So this is the first one, the entry cam. So the only thing that we actually have to do here is store that entry state until some later time when we reach the end of the trajectory. So I'm going to create a new vehicle state object, which is just a simple container object, or I think it's a record actually, with a couple of properties. So I'm going to new that up. And then I need to use Dapr to save that state. Now, there are a couple of ways to do that. I could simply use an HTTP client and make a direct HTTP call to that sidecar because it's an HTTP API. But it's much nicer to use one of the language-specific SDKs, and there are a lot of them. Of course, there's C#, so I'm using the .NET SDK, but there are SDKs for Python, Java, Rust, Go, I think PHP even, JavaScript, a lot of languages. So to use this SDK, I've added a NuGet package to this project, and then up here at line number 4, you can see me calling add Dapr client, so that registers some client services into the services collection. which in turn allows me to, in this handler here, inject a Dapr client. And I can use that Dapr client object to interact with my sidecar. So it exposes stuff like save state. And then in save state, I can pass in the name of the component that I want to use, which is state store. So if we go back to the bicep modules and we look at state store, here is my state store component. You can see it has the right name. It's of type Cosmos DB. And then I have some metadata to tell Dapr how to connect to the actual Cosmos DB. Now notice that for the master key, I haven't put it in here in plain text because this will get pushed up to GitHub and it's no fun pushing your secrets up to GitHub. So instead I'm using a secret reference, which references this secret store here, which is not a Dapr building block, which we'll get into later. So the other parameters here are the key that I want to store and the value that I want to store. And then I'm done. Dapr does all of the hard work for me. I didn't need to use any Cosmos DB specific code or SDKs here. That's all being done by Dapr. Now, as soon as we reach the end of the trajectory, we get an exit message. And the first thing I need to do is to retrieve that entry state from the state store. So I can use that Dapr client again, call getStateEntry. We should have that state, right? Because every car should have gone through the entry camera before reaching the exit, but this is all still software, so I'm checking anyway. So if I don't have it, I just return a not found. If I have found it, I'll update that state with the exit timestamp and just save it back for good measure. And then we can do the useful businessy stuff. We can use the calculator to determine whether or not we have a traffic violation on our hands. So we get back the speeding violation in kilometers per hour. So if that's a positive number, then we'll just go ahead and create that event that we want to publish. So speeding violation detected, which contains a bunch of information like the license number, the road, and the actual violation. And we can publish that again simply by using that Dapr client. So, sorry. At this point, it would be nice to see something running, but unfortunately, we need to have a little talk about this because here I'm running into what I think is a pretty big limitation of container apps at the moment. So I have this, what I think is a very nice visual simulator that I've spent way too much time on, and it can generate that traffic and it creates those events. And it wants to send those events to Mosquito over MQTT, right? Unfortunately, my visual simulator is running inside a browser. So I'm in a browser sandbox and I want to create a direct TCP connection to some MQTT port on the internet. And that's the point where the browser says, no, you are not allowed to do that. Now, fortunately, Mosquito has a solution for that. We can use MQTT over WebSocket. And the way to set it up is you create a second listener in Mosquito that usually uses port 9001. And then from my browser, I am allowed to create a WebSockets connection over 901. So I can stream MQTT over WebSockets to Mosquito. That will work. And then the Dapr sidecar can still use the direct MQTT connection. So everything works out fine, unless we're only allowed to open up a single port out of ACA. So this is a real bummer. And it doesn't even matter if you want to expose a port to other internal services or to the outside world. It's just you get one port, one ingress. So that little snippet of bicep code I've shown you with the ingress, I would really like that to be an array, but it's not. So I can only choose between one of these ports, and that's simply not good enough. So what to do here? Well, I do have this other simulator, which is a console application. So it doesn't have any sandbox it's running in. It can just talk MQTT to that endpoint. So that will work. But it's just not as nice as the visual one. So I really like that upper one. So I'm going to over-engineer a solution out of this. I'm going to just add a whole different application, which will act as a bridge. Right? So I can create an HTTP endpoint that my visual simulation can talk to, and then my simulation gateway can talk to that same MQTT endpoint. I can use a Dapr output binding for that, so I still don't need to program MQTT stuff myself. But this is just a way around that limitation for now. Notice, by the way, that my simulation gateway is simply running on port 80 and that I'm exposing an HTTPS port to the outside world. And that's because of this very nice feature that ACA has. It can do TLS termination for me. So application connection. Actually, if the application tries to connect to the HTTP port, by default, ACA will redirect it to the HTTPS port, then do TLS termination, and then call my container app. So this should work. Emphasis on should. So let's see. So somewhere in this solution is my visual simulation. Yeah, oh, I actually don't need the code, or I can show you the code really quick, actually. No, not this one. I meant to show you the code for the simulation gateway, which is this. So this just consists of these two endpoints. These are called by the visual simulation, and the only thing I need to do here is invoke that Dapr binding to just push everything through to Mosquito. And I can simply reuse those existing entry cam and exit cam components that I've already got set up. Now I'm going to start this visual simulation, which is just a .NET application hosting a website for me. And then you should be able to go to port 5000. And we have these nice cars driving around on the road. We can follow them a bit, see if they reach the exit, maybe zoom out so we can see the whole trajectory. So while they are driving underneath these cameras, events will be generated and pushed up to that surface. And actually what I'm going to do, because as soon as I do this, the animation stops and it stops generating events. So just to keep that flow going, I need to keep that window at least somewhat visible. So I'm just going to put it slightly behind here, and this will work. So now if we start up, because this is timed out, but if we connect back to the logs, oh, and I want to connect to the traffic control servers, you can see the entry and the exit events going by. And if you have really sharp eyesight, you can also see some speeding violations in there, but they tend to scroll by pretty quickly. So this is working great. The simulation is going through that simulation gateway, it's going through Mosquito, and it's pushing it up into this traffic control service. All right, let's pause this for a minute here. And let's talk about the next service on our list, which is the find collection service. So the traffic control service has done its thing. It can detect speeding violations, and it publishes a speeding violation event whenever it encounters one. And then the find collection service needs to subscribe to those events and do something with it. So this works in the same way as the input binding did. So you may say, hey, isn't there some kind of overlap? Why aren't you using the pub/sub building block for the MQTT gateway? That would be a fair question. So there is some overlap between bindings and pub/sub. The main difference is that bindings don't care about message brokers. So you may create a binding for a message broker, but it doesn't have to be a message broker. So bindings can integrate with all kinds of things, whereas the pub/sub message block really has to work with message brokers. And because of that higher level of abstraction, it provides a little bit more features like message deduplication and routing and tracing. And to provide those features, it needs to wrap those messages inside a cloud events envelope. Now, I don't care about cloud events at the side of the cameras. The cameras don't know about the cloud events format, so I just want to work with raw basic payload. So that's why I'm using bindings on that side and the pub/sub building block here to integrate between services. But it works basically the same way if you set this up. So you subscribe to some topic on the Azure Service Bus, and then whenever a message comes in, the Dapr sidecar will trigger my application to do the actual processing of that message. Let's look at that processing. So we need to calculate an exact find amount. So let's say that we use some common off-the-shelf product called FineCalc to do that for us. And in order to use FineCalc, we need to have a license key to FineCalc because this is a commercial product. So I need to store that license key somewhere safe. It's basically a secret, right, that I need to store somewhere. Now there are two ways I can store this. So first of all, ACA itself has a secret store, which simply uses the underlying Kubernetes secret store. And that is really great if you want to reference those secrets from scaling rules. So you have a service bus scaling rule, which needs a connection string to the service bus. You can put that inside of ACA secrets. But it's not so great if you want your Dapr applications to be portable, because I also want to be able to run this solution on my laptop, right? And then I'm not running inside of ACA, so I don't have access to any built-in secret store of ACA, so I want to have something else. And that something else is, of course, a Dapr building block, in this case, Dapr Secrets Management. So I can set up a component to talk to a secret store, which in this case is going to be Azure Key Vault. And then whenever my app needs access to a secret, it can just like with all the other building blocks, it can make a request to the sidecar and it will get the secret from the Key Vault. And then if I run it locally on my application, most of the time I simply use a Dapr secret store component that stores secrets in like environment variables or JSON files, stuff that's easy to test with. Okay, so now we can get the license key, we can call FineCalc, so we get the fine amount. Then we're just about ready to send the email, but in order to do that, we need some more information on the vehicle and on the vehicle owner. Specifically, we need to know the email address of the vehicle's owner. And we can get that information from the vehicle registration service. And that's a really simple service. It just exposes an HTTP API that we can query. So we could do that directly, right? Just new up HTTP client, make the call. Not too much work. Or we could use Dapr service invocation, which will offer us some benefits. So if I use Dapr for this, I'm not making a direct call. Instead, of course, I'm calling my local sidecar. Then the sidecar can do service discovery, so it can discover where the vehicle registration service actually runs. It forwards that request for me, and then the remote sidecar will call into the actual servers, and then any response will flow back the same way. So why go through all of this trouble? Well, there are a couple of features that you get from Dapr. So first of all, Dapr can automatically secure that channel between those sidecars. So it's a little bit of added security by using mutual TLS. You also get automatic retries. So who here is using Poly in their .NET services? Quite a couple of you. So with Dapr, you don't need to code that yourself. You can just create a retry policy and configuration, and your Dapr sidecars basically do that retry for you. So that's very nice to have. And then finally, because all of the traffic flows through the sidecars can really help you with observability and things like distributed tracing and writing stuff down to application insights like analytics. So there's some nice benefits that you get. So now that we have that information, we can really start sending that email. So for that, I'm using a nice application called MailDev. Who is familiar with MailDev? Two people. It's really great if you want to test sending emails, because it's basically, it exposes an SMTP server, and if you send some mail to it, you can view it in this really nice UI, and you can check if it worked and if the email looks like you intended to. So it's really nice for debugging and for demos like these. So I've set up Ingress for port 25 for that SMTP, so that I can use a SMTP output binding to send that email. Now this binding was actually created by a buddy of mine, Edwin van Wijk, who wanted to try creating a new component for Dapr. It's all open source, so if you know any Go, or if you don't know any Go, because Edwin also didn't know any Go, but if you look at some of the other components, it's not that difficult to pick up. You can create your own component and then contribute it back to the project. So my code, again, doesn't need to know anything about SMTP, simply going through that binding. All right, so let me show you some code for the Define Collection service. Let's make some room here. Let's close this one, close. What's this? Don't need this. Fine collection service program. Same thing. I'm using minimal APIs here. So to subscribe to those speeding violation events, I have this event handler. And for the PubSub building block, I'm using this with topic methods to do the actual subscription. So here I'm telling Dapr I want to use the PubSub component named PubSub, so pretty good name, and I want to subscribe to the speeding violations topic. And then whenever a message comes in, please call this endpoint for me. So in this endpoint, the first thing I do is I get that license key from configuration. So you may wonder, how did that license key end up in configuration? Because I had it stored in the Azure Key Vault, remember? So we scroll up a bit, then all that magic is being done through the add Dapr secret store extension method here on the configuration manager. So what this does is I tell it which secret store I'm using, and then it will get all the secrets from that store. It doesn't have to be all the secrets, by the way. If you just want to get a couple of keys, you can also specify this in an overload. But in my case, it's getting all the secrets, and it's putting them inside of the .NET configuration framework. So it's available as you would normally access configuration stuff. Now this parameter here is a delimiter that I want to use to create hierarchies. Because in .NET, configuration has hierarchies. So this means that if I have something like this in my key vault, like connection strings, database, double hyphen. This will get parsed into a connection string section with a database key under it. And the reason I'm using double hyphens here is as that separators, because Azure Key Vault actually only supports alphanumerical characters and hyphen characters inside the key names. So that will load everything into .NET configuration, and then for my actual code, I can just reference it like this. All right, so now I have the license key. I can use the fine calculator to calculate that fine amount, passing in the license key and the violation. I get back the amount of euros. And now I need to make that call to the vehicle registration service with Dapr service invocation. And there are a couple of ways to do that. The way I'm doing it here is what they recommend, and that's by using a special type of HTTP client. So I've created an HTTP client by calling this Dapr client create invoke HTTP client, and that will new up an HTTP client for me, but with a very special message handler. And that message handler allows me to use URLs like this, which are really compact and functional. So the host name here in this URL is the Dapr application ID of the application that I like to call. And then Dapr will do the service discovery and discover where that application actually is. And then all the other stuff in the URL is simply the route that I want to call on that application. So what that message handler actually does under the hood is it will take this URL and it will rewrite it to something like this, to a call on my local sidecar, which is running on 3500. Oh, great, it's auto-completing. Saves me from making a lot of typing errors. So it will rewrite it to this way longer URL, which is a call to my local sidecar, and that will perform the actual request. So being able to use just HTTP client with those shorter URLs is really nice if you have an existing application that you want to Daperize, because then most probably you only need to change some host names here and there, and you're done. So now that we get back the vehicle info, I can put everything together and inform a couple of other components that I've now calculated the fine. There are more than one component that wants to know about this, so again, I'm going to do this using events. I'm going to create a fine calculated event which contains that fine amount and also the email address and some other stuff like the vehicle brand and model. Don't know why that's a thing, but it's in there. And then I'm going to publish that event back to the service bus, so anyone interested can now handle that event and do some cool stuff with it. And the first component that's interested in this is actually the fine collection service itself. Because this is listening on that fines topic and it's forwarding calls to the fine calculated endpoint. in order to send that email. But now it's nicely decoupled from each other. So here we first create the email body, then we set up some metadata like the from address, the to address, and the subject. And then I can call the invoke binding to execute that SMTP binding, and that will send the email. So let me see where we are. This would probably be a good time to show you those emails and that it actually works. But unfortunately, surprise, surprise, we're running into that same annoying issue. Because this is the nice UI that MailDev gives me. It's running somewhere in the environment. I've already got port 25 set up for SMTP Ingress, so I cannot set up a different port to access my UI. So now I have this UI, but again, because only one port can be used for Ingress, I cannot reach it, which is pretty annoying. And we'll have to over-engineer another solution for this. So this is another container app I've created just to create an alternative dashboard to view the fines. So it will need to have access to the fines data as well. So the way it's going to do that, it's going to subscribe again through Dapr PubSub to those same fine calculated events, and then I'll create a materialized view, put it in an Azure SQL database. And I'm just using normal entity framework for that. So I don't use any Dapr for this. We may want to do some more complex queries in the future on that data, so Azure SQL seems to be a better fit for that than Dapr State Management. Basically, then the only thing I have to do, is set up Ingress for this, and then anybody who knows the URL can see that fine data. So that's great. That's also horrible, even for government agencies. This is really bad security if everybody who knows the URL can see the fines data. So we need to set up some authorization. Now, fortunately, ACA has this really nice built-in turnkey authentication feature. It's sometimes also called Easy Auth, and you may recognize this from Azure App Services. It's basically the same feature that they've also offered here. So how this works is when I set this up, I get some authentication middleware injected into the request pipeline. So that's just another container where the request goes to. So if the browser makes a request, it first hits that authentication middleware. That will take care of any of authenticating the clients and of managing the authentication sessions. And then it will forward the request to my traffic control UI. And you can use all kinds of identity providers with this. So I'm using Azure Active Directory. You can also use other social logins like Google, Facebook, Twitter, if that's still a thing. You can basically use any OpenID Connect provider here. And then there are two flavors you can use. You can tell the authentication middleware to only let authenticated requests through. So as long as the user is authenticated, they will never be able to reach your application. Or, and that's what I'm doing, you can set it to anonymous. And that means that unauthenticated users will also get through, and you can show like a homepage with a login button, stuff like that. So let me show you what that looks like. Let me first go to the Azure portal, and then I'm going back to the resource group, and here is my traffic control UI. So this is the app. And here up in the Essentials section, you can see the application URL. So if I go there, this is my nice dashboard. Let me see, scroll in a little bit. All right, so there's not much to this dashboard yet. I do have one option here to go to the fines. And as you might expect, if I go to the fines, I'm not authorized, which is exactly what I want. So that's great. So let me show you how this works in the code. Now, the reason I get that unauthorized is because in the app, and by the way, this is a Blazor server app. So on this page, I've decorated, I've added the attribute for authorized. So this will check, do we have an authentication token? No, we don't, so you're not allowed to see this page, right? So now we need to create that login code. So is this going to be difficult? Nope. This is really easy. So in our mail layout, I've just created, if you're not authorized, I'm creating a link, going to .auth/login/AAD, and I added the AAD part because I'm using Azure Active Directory. So what this means is all the requests with .auth will get intercepted by that authentication middleware, and it will take care of all the OAuth stuff that needs to be done. And then after that's done, it will redirect back to my application. So yeah, let's see if that works. So this is going to be quick because probably I'm already logged into Azure AAD, so it will just bounce back directly, or it may show me a login page. Let's see what happens. No, it's already detected that I'm already logged into Azure. So now I'm logged in. You can see it knows my email address. That's from a claim in the token. So how does Blazor know what my claims are? Right? Because the authentication was done by that other container. So how does it get access to that claims data? Well, that works with a HTTP request header. So if we go to the very start of my application, then you can see that I try to get this XMS client principal request header from the incoming request. Now this is only set if I'm authenticated. And it's basically a base64 encoded JSON document which contains my token and all of the claims that are set. Now, due to the way that Blazor Server works, you cannot simply access the HTTP context from anywhere in your application. So they recommend that you do it in the hostcs HTML. So here I try to detect if we've got that principal, and if we do, I deserialize it, I parse it into this MS client principal object, and I pass it into my application using this parameter syntax here. And that will inject it into this app.razor. And here, when my application initializes, I use my own authentication state provider. So this is an object that, well, does as it says on the tin, it provides authentication states to Blazor. And I've created my own called Easy Auth State Provider. So what this does is it will check if that client principal was set. If it is, we can create a new claims identity using all those claims and all that information coming originally from that header. If it wasn't set, we're unauthorized, we just create an empty claims identity and Blazor will recognize that as unauthorized. And then we wrap this identity into a principal, and then we wrap a authentication state around that principal, and that we return to Blazor. And now Blazor knows about our claims, and it knows if we're authorized or not. So going back, we can now go to the defines page, and this will work. Now let me just add some load on this. So going back here, we should see most of the time it takes a couple of seconds for somebody to drive too fast. But if all goes well, then yeah, there is a new one. And it's going pretty good actually. I think we are almost at 2 grand right now since I've started testing these demos. So yeah, it's a lucrative business. All right, I think I'm just about at time. So let me quickly wrap this up. So all in all, I really like Azure Container Apps. I also really like Dapr, but there are some definite limitations with the combination of those two. So first of all, and actually the most annoying of all, is that single port ingress. That really took me by surprise if I'm hitting it 2 times in what is a pretty simple demo scenario. And if I think through some of the production scenarios and my clients, I can think of a lot of examples where single port simply isn't good enough. There is some discussion in the GitHub issues about this, more people wanting this, but as far as I know, it's not on the official roadmap yet, but keep fingers crossed. Then the other pretty big limitation is around configuration. So all of the configuration I've shown you is at the component level. It's for configuring components. But there's an entirely other level of configuration in Dapr, which is called the application configuration. And you use that to set some advanced features, like you want to use some preview features, or you want to specify which service is allowed to call which other services, or you want to inject your own custom middleware in between your application and your sidecar. And those are nice and useful features, but I can't use those because ACA doesn't allow me to specify my own configuration file. Now, they may surface these features in different kind of way, make it accessible without you having to specify a complete configuration file, but most of these things here aren't available yet to use in ACA yet. And very quickly, the final thing is I cannot specify which version of Dapr I want to run, which may or may not be a big problem for you. So right now they are running, I think, what is 195 or 196, the latest version. And I believe I've read somewhere in GitHub issues that they aim to go to the new version like 3 to 4 weeks after the latest Dapr version has been released. But in the past, there definitely have been some breaking changes in Dapr. So I start to wonder, what if I'm running my production system and then they decide to upgrade from Dapr 1. whatever to Dapr 2? Is my system still going to work, or am I going to have to deal with breaking changes? So ideally, I do not only want to have a Dapr enabled or disabled toggle, but ideally I want to specify which version I'm using in my Azure container environment. All of that said, this is basically still pretty early days. The team is iterating pretty fast with new features. So yeah, it's going to be an interesting year to see if some of this will get on the roadmap. So now I'm definitely at time and I don't want to keep you from lunch. So thank you so much for joining me today. All of the source code is available on my GitHub. If you want to know more about Dapr, I've written a free ebook which is available on the Microsoft site. I'm a co-author along with 2 other guys. And I also have this .NET video webcast thingy, which you may also like. So thank you very much and have a great rest of the conference. Oh, and by the way, if there are any questions, I'll be here for the, coming minutes. And I'm here all week, so just find me at the conference if you want to chat.